Okay, so I'm going to just briefly sum up. So we introduced atoms a while ago. I said that this periodic table of elements is a list of all the different types of atoms that exist. And you can see it has we talked about these different numbers. We've got a mass number, an atomic number. It's got a symbol, and it's got a name, right? Now, to start off with, we can imagine that we can draw these different colored circles. Let's do that again. So let's say that this is one type of atom. Maybe it's hydrogen, and then this one over here is maybe oxygen, right? So that's hydrogen. So let's just label it. Let's write an H in it, so as we know it's hydrogen, and we're going to write an O in that, so we know that's oxygen. Now, water is actually a compound. Water's made out of oxygen and hydrogen, and it looks like this. Actually, the hydrogen's atoms are quite small, so I'm going to make that a bit smaller. The oxygen's atoms are a little bit bigger. I'll make that a bit bigger. I'll make the O a bit bigger as well. And actually, they're grouped. Well, the formula, and I'll just briefly introduce these formulas now. H2O, you might have heard of. What it means is there are two hydrogen atoms, and one oxygen atoms, and they're arranged like this. So they look like a water molecule looks like a Mickey Mouse head. So it's like this. So that is a water molecule. Now, you don't need to know the shape of the molecules, but that is a water molecule right there. And obviously a glass of water contains loads and loads of water molecules. So we can draw a few of those, and they won't all necessarily be arranged like that. They might be rotated. So they could be rotated in all sorts of different ways. But they would always be in a group like this. That each one of those is a water molecule. Okay, so this is a water molecule, and water is a compound because it's made out of more than one type of atom, and they're chemically bonded. All right, so that is water. But what we want to do next, really, maybe not immediately, but quite soon, we want to think about what would happen if we looked even closer into these atoms. Maybe let's have a brief look at that now. What would, if we looked really, really close inside? Obviously, at the moment, I've just drawn circles, but I'll show you what an atom looks like really close up. So very, very, just a brief introduction. All atoms are made out of electrons, protons, and this one has just been clipped off the end. That's neutrons. And they all have different numbers of electrons, protons, and neutrons, and that's really what determines the difference. Actually, the main thing that determines the difference between one atom and another is entirely the protons. So if we look back at this periodic table, we had this atomic number, 1, 2, 3, 4, and so on. The atomic number, and I said I was going to say this at some point, so I'll explain it now. The atomic number is the number of protons. So atomic number tells you the protons. And I won't go into what the mass number does yet, but the most important thing is the protons. The protons is what tells you what element it is. If it's got two protons, it's helium. It doesn't matter about the number of electrons and neutrons. You can mess around with that all you like. It's still going to be helium because it's got two protons. If it's got 6 protons, it's carbon, and so on, so on. All right? So we're going to look a little bit more at that eventually. But to start off with, we can just draw these colored circles to say that that's maybe an oxygen atom. This is a hydrogen atom. And then we can group them together into these molecules. We're also going to look at some of these atoms or some of these elements are metals, some are non-metals. I'm just going to draw a zigzag line to show you where they are. If I draw it, what you do, I think, is you just remember something like aluminium, and you go Aluminium. Aluminium's a metal because it's made out, you get aluminium drinks cans, don't you? So I draw a line above the aluminium. Boron is not a metal. I'll draw it around there, and I just keep zigzagging down after that, and that shows me where the metals are and the non-metals. All the metals are on the right, so there's not that many. Sorry, on the left. All the metals are on the left. So there's loads of metals. All the non-metals are on the right, so there's not that many non-metals. So that's just an introduction to the periodic table and atoms.